Thanks, Christy. Hey, it's really nice to be here. I'm excited to talk a little bit more about Databot and welcome to all of our participants. So I've been involved in STEM education for over 30 years. I've taught everything from early Lego robotics through coding and sensor science and a lot of other fun things. So I've had a lot of experience working with the kinds of things that you're going to be seeing here shortly. Databot is a new product, which we're really excited about. It's been on the market now for just about a year. And Studica is one of our partners that can help you get Databot. Once you see it in action, I think you're going to be excited. So with that, what we're going to do today, we're going to take a look at Databot, how it works, and the sensors that are available. We're going to be focusing on environmental data. There are a number of sensors in there that are for motion and physics as well, but we're going to be spending most of our time on the environmental piece. We're going to introduce Google Science Journal. If you're not familiar with it, it's a great product from Google that connects to Databot and allows kids to actually build multimedia science portfolios. I'm going to give you a couple of specific examples of indoor and outdoor environmental explorations so you can see how we can actually use these tools to get kids involved. One of the nice things about them is they're very simple, very easy to use and access. So that's one of the neat things about this particular combination is it makes it really easy to quickly grab data and have talking opportunities with kids as they find data. We're going to look at two of the resources that I use pretty frequently when I'm developing some of these materials, Project Learning Tree and also the Environmental Protection Agency. And then there's going to be a chance for everybody to ask questions and we'll provide answers. And then at the end of this, Christy will be able to send everybody a copy of this presentation. So if you want to go back and explore the links or have other questions, you can always contact us and follow up. So with that, let's go ahead and get started. So Databot, this is a picture of Databot. It's a small device. I think maybe this next one actually gives you an idea of the scale. So if you look at it in my hand there, that gives you an idea of its size. It's 1.67 inches on the side. And what it is a sensor cube, and it has all of these sensors that are listed built in. So you'll notice that the ones that are on the left-hand side and then the top two on the right all relate to environment. So there's a lot of different kinds of things that you can do with it. It is rechargeable. It's got a built-in battery. I'm going to walk you through Databot anatomy quickly so you can kind of see what it looks like and how it works. But one of the nice things about it is there's no wires or cables, batteries to worry about. You basically plug it in to charge it, detach it, and then use the wireless Bluetooth connection to grab data and visualize it on different software. So a quick summary of the sensors there. You can see there's an external temperature probe. You'll see a picture of that shortly. A humidity sensor, UVA, B, and an index that's calculated. Also your ambient light in the room or outdoors. You've got carbon dioxide, volatile organic compounds, both of which we're going to look at today in those sample experiments. Air pressure, altimeter. The altimeter actually calculates your altitude from the air pressure, excuse me. And then you've got sound, and then there's also the physics package. So here's just a couple of examples of Databot being used in the field. On the left-hand side, this is an example of strapping it to a Estes Air rocket. So it's really nice, again, since it is wireless, you can capture data from real-time things like that. It's very rugged. It also comes down, on its nose from that rocket and has survived many launches. So it can handle a drop test pretty easily in the classroom. The second picture there is an example of gathering UV readings just outdoors and using a tablet and Google Science Journal. That's actually Science Journal that you see there. On the right-hand side, you'll notice that we've got a Chromebook featured there because you can connect it to Chromebooks and easily use it in a classroom full of Chromebooks to gather data. And then down on the lower right-hand side, I've actually got a couple of other pictures I'll show you as we go through Databot anatomy. but it integrates with a variety of robotic systems. So if you're technical program or you are a technical program person, there's lots of things you can do with it as well. So quickly, we'll go through Databot anatomy. And this is the front face of Databot, and this is what we call the main sensor board. So on that sensor board are most of the environmental sensors, and you'll notice some penetrations in the case there as well. The upper right-hand corner, that's where the volatile organic compounds and CO2 sensor is. In the center, there's a light sensor, so that's it reads out in lux. The ultraviolet, I'm not sure if you can see it in that picture, but there's actually an opening over the UV sensor. It's about in the middle to the left a little bit. Since the case is polycarbonate, polycarbonate has natural blocking characteristics of UV rays, so there's an opening. And when kids go outside to test UV readings, just like I did here in this picture, you actually can focus a little shadow around the sensor and get a really pure UV reading. It actually projects the circle, I call it the shadow site, right onto the circuit board so that you can actually capture really clear readings of ultraviolet. Also on the front there, there's a microphone. That's the other opening on the upper left-hand side. So lots of sensors built in there. If you look at the side view of the Databot, you can see the rest of the boards. There's a lot of material packed into this little box, which is how we got all these sensors built in there, is through using multiple boards. So as you go back through the other boards, you'll see there's air pressure, altitude, humidity in addition. And then that's also where the physics package is. There's an accelerometer, gyro, and magnetometer. There's also speakers, and a built-in SD card, and then you've got all of your I/O and Bluetooth. So there's lots of ways to connect to it depending on the device and your application. And one last shot. Let's see that, and then I'll show you the bottom actually too. This is the external temperature probe that you can drop into a beaker or a stream. The experiment that I did outdoors that I'll show you here in just a few minutes, we were using the external temperature probe, and we used it both for ground temperature as well as air temperature. And it plugs into that port that you see on the Databot top. That's a top view of the Databot. And you'll notice there's some other expansion ports and also the charge port. And then this is a bottom view. One of the interesting things, again, this thing was designed to integrate with other technical systems. So it's got hooks for Lego, Fisher Technic. It's got a Velcro plate that slides on there. There's all kinds of fun ways that you can integrate it with both physical and electronic systems. And then this is a quick look at the actual kit contents. This is what you get if you actually purchase a Databot. And it includes everything, including the SD card, which comes pre-installed, a lanyard, charging cable, the external temperature probe, and then all of the sensors that are built in. And that's one thing I have to go back and remind people of, because they ask, well, where are all the other sensors? Well, they're all built into the cube. So everything was pretty much self-contained in that cube. So now that you've seen Databot, that hardware connects to a number of different software packages. So for example, the one we're going to look at today is called Google Science Journal, and that's the one on the far left on your screen. And Science Journal is really easy to use. It works on Chromebooks, which is great if you're going to be using it in the classroom, because lots of folks have Chromebooks out there, and this actually boosts the capabilities of your Chromebooks greatly. And it allows you to not only visualize data, but you can record it. And then you can also add observations, such as text observations, or take pictures, which when I did my environmental study outdoors, we did a lot of pictures that kind of built up a portfolio. So you could see the environment where we took the readings, and also see all of the data behind it. Other ways you can connect to Databot. It connects directly to Excel. If you're using a current version of Windows 10 and Office 365, it'll actually feed live data right into Excel. And this little dashboard that I've got displayed in this middle screen gives you an example That's actually taking environmental readings there of temperature, light, CO2, and humidity. If you don't have a current version of Excel, you can actually export the data or use this SD card, and it writes CSV files, which will load into just about anything. And then finally, VFox. This is a new one that we're releasing shortly. This one is available for all smart devices, runs on both iOS and Android, as well as Chromebooks. And that one's great. I'm an iPhone user, so I can actually take Databot and VFox and grab data wherever I go. I can do it on an airplane or an apartment. Makes it very portable. So let's take a quick look at Google Science Journal. This is the software that that we used for these experiments, and it's, I think, probably the easiest to use for most teachers. For most of you out there, if you're using Google Education, this is kind of a neat integration because it'll actually sync with your Google Drive. It allows students to take pictures again and not just grab data, but you can take physical notes and build those into a really colorful multimedia portfolio. So it's a neat science documenting tool. Does sync with Google Drive. So if you're using Chromebooks, for example, and you implement that, regardless of what Chromebook a student logs into, they'll be able to access their portfolio. There are some IT issues to enable it on Chromebooks. You have to enable the Android Play Store, and there's lots of information out there about how to activate it if you want to get it on Chromebooks. All right, so with all of that background, I apologize if I'm talking too fast, but we're already almost halfway through our time, so I'm trying to cover a lot of information here. So we've looked at the hardware and the software, and now I'm going to give you a couple of different examples, one outdoor and one indoor, that show you how you can use some of these environmental sensors in an activity. So this first one, we did a outdoor field trip. Upper left-hand corner, that was my companion. That's Lola, my daughter's dog. And she helped me take readings all over the place. You can see our route there. It's about a 2-mile route. And one of the nice things about this particular hike is that it has multiple altitudes. So we live in the foothills, and so we were able to take readings of CO2, humidity, the air temperature, the soil temperature, air pressure, all within an hour at different altitudes. And you can see in the picture on the lower right-hand side, you can see some of the different types of data we were collecting. You'll notice the thermometer, or the temperature probes, actually buried in the ground. So we took both air temperature and soil temperature. And an interesting experiment that somebody was talking to me about is actually taking soil temperature readings over the course of the year. And you'd be able to do that with the temperature probe, and you would be able to drop it down at different levels. So for example, if you had a marked stick, you could take readings at, maybe 20 centimeters, 15, 10, 5, and then at the surface, and see, how the ground temperature changes over the course of the year. That would be a great environmental investigation for kids. So let's take a look here. The left-hand side, just to the left of where the temperature probe is, that's actually a screen capture of what Science Journal looks like. So I'm actually inside one of my experiments, and you can see at the top there a display of a series of recordings. So if I were to click on that where it says temperature probe, it would open up and show me the other sensors that had been recorded there as well, which includes all of those to the right. And you'll notice that I annotated it. I said that's the reading at 778 meters. So you can see that we're taking notes. We can see the altitude. We actually captured the altitude with the altimeter, and all of that other data and pictures of the environment we were in were captured right along with it. So it becomes a really great tool to go back and reference the data that you did collect and the experience overall. So here's some results from that particular one. Now that we took a lot of data, I just did the altitude and CO2 and air temperature to give you an example. And this is a great one for introductory discussions with kids about carbon dioxide, what's causing carbon dioxide levels to increase in the world, The image there to the right is a snapshot of actual CO2 readings that have been taken since 1958. Mauna Loa Observatory in Hawaii is probably the most well-known source of that information. That's what everybody kind of looks to. A few years ago, in 2016, we passed the 400 part per million level, which was kind of a big barrier that had never been seen before. And the Databot is actually an indoor air quality sensor and has a floor of about 400 parts per million, so it doesn't read below that. But in our exploratory field trip, all of the CO2 readings were actually well above 400. So that's both concerning and educational. And it was a very clear day. If you go back and look at the pictures that I was showing you, we have inversions here occasionally. We're going to go out and do another round of studies when we have a temperature inversion and the air is a little bit hazy. And over time, see what the CO2 levels do. And you can see there we compared it against altitude. CO2 levels went up as we went down, which you'd kind of expect because CO2 is heavier than air. And of course, it was a pretty still day, but there's wind and movement. There's a lot of things that you can talk to kids about in terms of what's impacting the data, what can we do to make the data more clear. Once you start experimenting with it, and the nice thing about these tools, again, is they're so portable, whether you're using just a smartphone or a tablet like I did here, it's easy to grab data and start visualizing it, talking about it, changing the scenario. So let's try to change something. Let's block the wind and let's see if that changes things. So these are some example questions of, that are great probing questions for getting kids started with things like CO2 investigations. This is a great resource that I wanted to introduce folks to. There's a program and an organization called Project Learning Tree, and it's at plt.org. They have lots of great free resources, and they are a nationwide organization, and most states actually have a PLT coordinator who's just fabulous. Ours here in Idaho is really helpful anytime that I need some suggestions or insight about different things regarding, environmental studies. That's what they do, and they have lots of great materials. They also have a program called Green Schools, which is open to all schools to participate with. And they provide you with materials that enable kids to actually learn more about indoor air quality, environmental impact, and helping to make their school safer, more green space. So it's a really neat program, something I recommend taking a look at. Okay, second example of an exploration using the environmental sensors, and this one was inside a classroom. So the mission here was to hunt for dangerous fumes. And what we did is we introduced kids to the concept of volatile organic compounds, VOCs. That's one of the things that the Databot sensor reads. Now, volatile organic compounds are compounds that they basically evaporate at room temperature. And anytime that you've used a chemical cleaner, or if you've walked out in the garage and you smell gasoline, those are all very good examples of volatile organic compounds. Now, VOCs are very common in all kinds of materials. I'll show you a few examples here in just a minute. The one that we were having kids hunt for was xylene, which is actually a furniture stripping product, like paint thinner. And it emits these fumes that are really, you can smell it pretty quickly. What we were having kids do is try to identify the source of the dangerous fumes in the room without actually smelling it. We were using the Databot to sense. And the format we did here was missions, where we broke kids up into teams. One student would be the pilot driving the Sphero RVR that you see there. We mounted Databot on it. And the other person was using a Chromebook to gather data and for each site. The picture there in the middle, you can see somebody working with one of the girls actually mapping out their course, because there were 3 different locations where you had to go and look for the VOCs to see which one was dangerous. And part of it was timed, so you had to be very efficient. So part of the whole thing was planning, learning to work together. One student would have to collect the data. The other person would have to be running the robot and actually getting it to the site to gather the data. So a really neat program that had a lot of neat things with kids working together and communicating and Wasn't easy because navigating the RVR was more difficult than we expected. But they all did great, learned a lot. So here's some discussion points about VOCs. And you can see on the right-hand side there, some VOC readings that we took of common cleaners. So this is a great exploration that is good for kicking off something like the mission that I just gave you an example of. Using Science Journal and Databot, we tested 3 different household cleaning chemicals, glass cleaner, a 409 surface cleaner, and then Clorox gel cleaner. So you can see the different levels that each one produced. The glass cleaner, which has ammonia in it, had the highest, and then from there it goes down. One of the things that this kind of an exploration is fantastic for is to get kids more aware of chemicals in their house, things that might be emitting harmful fumes, because long-term exposure to VOCs can be harmful. So you can do treasure hunts in the classroom and try to identify different types of materials that might be emitting them. Furniture actually emits VOCs, depending on the type of coating it's got. Another good example, magic markers or dry erase markers. If you pop the top off of those, you'll immediately get a reading for VOCs off of them. Anyway, it's a great awareness activity, and one of the things that this is another resource, and this one's specific to indoor air quality especially. The EPA has been doing a lot of work on volatile organic compounds and identifying just how harmful they are and how prevalent they are. So making kids aware of sources of things like those VOCs is really critical, and this is a great hands-on way to do it in a fun way. All of these things, again, when you're using something like Databot as a sensor device and maybe a smartphone or a tablet or a Chromebook, it suddenly makes all of this invisible, abstract data very real. And that's one of the most fantastic things about being able to do hands-on work with sensors like this so easily, is because suddenly kids can actually start to interrelate with data. They can interact with it and do things like I was explaining before, where, well, let's change the scenario a little bit. Does it change the data? What are the things that impact the world around us? So great resources at the EPA. It's just epa.gov. They've got lots of lesson plans, teacher guides, lots of really clear explanations, and also webinars. I've attended a couple of their webinars where they go through in great detail things that are impacting indoor air quality or other issues related to environmental education. So EPA, highly recommended. Tax dollars at work. And that gets us to 124, where we've got just enough time, I think, for some Q&A. The presentation index that's attached to this that Christy can send out afterwards includes all of this material so that you can go to those links and get more information. And with that, I'll turn it over to Christy for some questions and answers.
Hi, Robert. One of the questions I saw was, as a teacher, what support materials or where do I go to get all this great information to make the most out of Databot in my classroom?
Yeah, so there's a number of sensor starters that are on our website that kind of walk you through how to use the actual sensors. And then in our blog, we've got lots of explanations of different kinds of data games you can play with kids. So Huff and Puff is a good example. There's a blog entry on there about that one where you have kids compete to see who can get the highest level of carbon dioxide. And you can do that in different ways. You can have them do it just by exercising or holding their breath, things like that. Or you can open it, open it wide open and tell them, using all of your scientific knowledge, what can you do to produce the highest level of CO2? So lots of materials like that are available.
Okay, and then we have another question. Do the temperature sensors with water and other liquids, I'm assuming that's work with water and other liquids?
Does let me clarify that question. Does the temperature probe work in any liquid?
Yeah, it says, does the temperature sensors, I'm assuming, work with water and other liquids?
Yeah, absolutely. It's waterproof. So yeah, you can drop it into a beaker, you can drop it into a stream. Databot itself is not waterproof. So because it does have case penetrations, we don't recommend dropping it into a pond.
Gotcha. It looks like that's all the questions we have.
Great. All right. Well, thanks for having me today. And any other additional questions, we're here all the time. So just forward any additional inquiries, and we'll be happy to give you more details. One of the things in the appendix, there is a link for the technical info. So for those of you who are looking for more detailed information on the sensors, so detailed spec sheets on, you know, what the range and resolution, those kinds of things, that's all available right on our website. If you go to just the URL there /geek, it's called Deep Geek, has all kinds of information for you about the kinds of data you can collect.
Great. Thank you so much, Robert.
Thank you for having me.